In this example, we need to find the derivative of y with respect to x by using this implicit differentiation technique. And we have given here an implicit equation as y times sine of x squared is equal to x times sine of y squared. So let's try to find the derivative of y with respect to x from this implicit equation. There are actually two steps to in the implicit differentiation to find the derivative of y with respect to x, right? What is the first step? We need to differentiate with respect to x on the both sides. So let's try to do that first. So I'm going to differentiate with respect to x on this expression over here, y times sine of x squared on the left hand side of this implicit equation, and I want to do the same thing over here on the right hand side. Differentiate with respect to x on this x times sine of y squared. So let's do that then, right? So let's differentiate. So how do you find the derivative of this function over here with respect to x? As you can see here, this is actually, we have the y variable, which is actually, it's depending on x because of this implicit equation over here. So we can think this is actually kind of a function of x, right? So, and then multiply with this function sine of x squared. On that case, we can see here is the product of two function of x. So on that case, we can use the product rule to find the derivative of the given function, right? So on this given expression, if that is the case, let's do that. So how to use the product rule? We write down the one of the function as it is. Let's say the first function y as it is, multiply by the derivative of the second function, and then plus we need to find the derivative of the first function with respect to x, multiply by the second function as it is, and this is the derivative of the expression with respect to x, right? For the left hand side, we do the same thing on the right hand side. And then also we have the similar type of behavior here. We have the product of two function, then we can use the product rule, which is leave the first function as it is, multiply by the derivative of sine of y square with respect to x, and then plus derivative of x with respect to x, so that we do the derivative of the first function, multiply by the sine of y square as it is. And so this is, I just try to apply the product rule. So until now I have not figured out the actual derivative of this expression, so let's try to do that. So now we have then y, which is as it is, and then derivative of sine of x square with respect to x can be figured out by using the chain rule, right? Why? Because the sine function composed with x square, and whenever we have a composite function, we can use the chain rule. So how do you apply that then? We need to know what is the derivative of the sine with respect to x, which is cosine, right? And then since this sine function is composed with x square, so the derivative need to be composed with that, and don't forget to then multiply by the derivative of this x square with respect to x, which is just 2x. So cosine of x square times 2x is the derivative of sine of x square. Okay, plus, and we have dy over dx. I mean, in the abbreviated form, if you want to write that down, this is just y prime, right? And then times sine of x square, we can write it down, is equal to x times, now we need to do the derivative of the sine function composed with y square. Remember, this y is actually function of x, right? So we have sine of some square of some function of x. So if that is the case, again, it is a kind of a composite function, so use the chain rule. So how can we apply then? We need to know what is the derivative of the sine x, which is cosine x, but since sine function is composed with y square, so cosine need to be composed with y square, right? And then we need to now multiply by the derivative of y square with respect to x. So how do you find the derivative of the y square with respect to x? We need to know what is the derivative. So we know that the y is a function of x. So we have something like a situation where we have a square of some function of x. So if that is the case, we can use the generalized power rule, or the chain rule, whatever you wanna call it, right? Which is bring the power down, write down y as it is, subtract the power by 1. So 2 minus 1 will be 1. So just 2y times derivative of y with respect to x, which is in the abbreviated form. We can write down y prime. So in that case, derivative of y square with respect to x will be 2y y prime. So let's write that down here then. So cosine of y square times 2y y prime is the derivative of sine of y square. Now plus derivative of x with respect to x is 1. So in that case, we have 1 times sine of y square, right? So this is the differentiation of the given equation with respect to x on the both side. So this is one of the first step of the implicit differentiation. The second step we do is actually to try to solve for y prime. To do that, we need to see which term involved with y prime. Let's collect the kind of let's make a group of the similar term. We have y prime here, this term also involved with y prime. I want to have those terms on the same side, and then since this term over here and then that term doesn't have the y prime, I want to move that, I want to group them separately. Okay, so let's do that. So why don't I also do this way? So whatever are the y prime term, let's move on the right hand side, and then whichever term doesn't have the y prime, move that on the left hand side. So if I want to do that, you can see clearly here we have y times cosine of x square right over here, and then times 2x, right? So this can be actually simplified as or rewritten as 2 times x times y times cosine of x square. Let's have that over here. Since this term doesn't have the y prime, move this on the left hand side. We can do that by subtracting the sine of y square on the both sides. So let's do that. Now this is then equal to, we have here this term over here, which can be rearranged as 2 times x times y times cosine of y square times y prime, right? And then this term has the y prime. I'm going to move that on the right hand side. To do that, I need to subtract the same term. So let's do that. So a minus y prime of sine of x square, right? So that's what we have over here. Now it's pretty straightforward that we can immediately, like, how to solve the y prime, right? Because we can isolate y prime in this way. We can actually first take the y prime out as a common factor here, and then the remainder will be 2xy times cosine of y square minus sine of x square here on the right hand side, and then on the left hand side we had 2xy times cosine x square minus sine of y square. And to solve for y prime, we just need to divide both side by this expression over here. In that way we will be isolating y prime. So we have then 2xy times cosine of x square minus sine of y square, right? This is on the left hand side. Everything underneath that will be 2xy times cosine y square minus sine of x square. That's how we can isolate the y prime and then get our required derivative. So we had the given implicit equation over here. Our goal is to find the derivative of y with respect to x, or let's say in the abbreviated form y prime, and that's precisely we have done over here.